Okay, I want to start by saying that uh, there is a teaching evaluation to fill,
Okay.
which I don't know whether you have done or not.
Yeah.
Oh,
Yeah.
oh, you have already?
Well, I usually do them all at the same time.
Okay.
So.
Okay,
Yeah.
then because we are told to give 10 minutes to the class to fill it in. Oh, oh, okay. Okay, not to put you on the spot or anything, but have you filled in the evaluation for this class?
I have not.
Okay, okay, perfect, actually. So I'm giving 10 minutes to do that. If you have already, then just relax, I guess.
Do you think we could do like the 10 minutes at the end? So then.
Oh,
Like,
okay, that makes sense as well.
okay.
We could do that, actually. Right. Okay. Yeah, actually, why not?
I was just
No, I
thinking.
know why. Because I know why. Because psychologically, if you put it at the end, there will be people who will just not do it and just go off. That's the reason why. But anyway, this class is not like that. So yeah, we could do that. Right. So let me give some stuff back. Okay. And I will, as usual, just thumb up some. Wait, was this the only thing? Yeah, this was the only thing. Yes, because the other one, did you bring the 34 that we
Yeah.
are going to finish today? Okay. So let me talk about, let me do, first of all, let me go over that group work that I just did. Um,
Okay.
I think so there should no longer be an item here
Yeah.
because this is just something. Okay. Okay, good. So let's do a very, very quick review. Have your group work 34, which is not complete, in front of you. Okay, good. So you have, yes, okay. Just a very quick recap. Remember how a likelihood ratio test, well, starts. You start off basically with a very generic statement of parameter is here versus parameter is not here, basically. Now, in the example on group work 34, you have mu is, I believe is 5, right? Versus not 5. So you see, so it's either it's here or it's not here. The other thing to note is the importance of, right, how is the likelihood ratio formed? Now be careful. The null hypothesis says theta is here versus theta is not there. They are trying to be more careful in the textbook to put this capital omega intersect WC here. What does this mean? Omega is basically everything. So omega, little omega, that W thing, that's a subset of capital omega. So I think from set theory, you know, if you really want to be very, very, very consistent, you can also say the null says theta is in capital omega intersect little omega. Because capital omega is everything. So when you intersect a smaller set, you get the smaller set. So what we are basically trying to say is the statement under the null and the statement under the alternative partitions your parameter space into two disjoint sets. And together, the union of the set stated under the null and the set stated under the alternative gives you everything. All right, so that has to be clear. Why am I talking so much about this? Because if you look at equation 652, we have to be careful. Equation 652 is how you set up the likelihood ratio. You want to find what's the maximum likelihood value under a maximization that's allowed to see everything only under the null. Whereas the one at the bottom is what's the maximized likelihood over everything, not in the alternative space, over everything. That's the difference. The alternative statement is not everything. It is what the null isn't. But the likelihood ratio is formed as the maximum likelihood value under what the null says versus everything. So it's actually an easier problem to write. So if you look at group work 34, what we have is a null that's extremely, the null says sorry, the null says fine. So when I say maximize the likelihood under what the null says, doesn't that just mean find out what the likelihood is when mu is 5? Because the null only specifies one dot. So that's a very simple problem. You just find L for when mu is 5. And that's what we actually did. I asked you to find L, where's the 5? L51, right? That's right. And then the bottom one is how do you maximize the likelihood if you are allowed to choose the mu among all real numbers. So that's where the maximum likelihood thing comes from the previous group work where you have found if you are unconstrained, what is the maximum likelihood estimated of mu? It is when you use the value mu equals to what maximizes the likelihood if you are allowed to choose any real number for mu? Right? The maximizer of the likelihood is the value. This is quite important. So you see, that's why this is crucial to understanding 652. The maximizer of the likelihood when you are looking at the null hypothesis has just got to be one number, 5, because you are only given one option. But what is the maximizer of the likelihood when you are allowed to look at any real number? What value of mu maximizes that likelihood if you choose mu equals to? Why, yes. And that is why there's those two statements in your, you have L5Y and Ly bar Y. What does that mean? It means the likelihood value when your theta is 5 versus the likelihood value when you stuck in the value Y bar for the parameter. Am I making sense? It's quite confusing, I understand. First of all, the likelihood is just a statement about all the densities, all the data you observe, and all the unknown parameters. That's in the abstract, a likelihood is just a density, and you've written that down. But maximum likelihood is what value of the parameter should I use that will maximize the likelihood. Now, if you give me such a small choice, like in the null, where I'm just going to say, oh, mu is just 5, then you have no choice. The likelihood is maximized at 5. As I said, you're the only one in the room. Who's the tallest in the room? You are. See? But now there's a room full of people. Who's the tallest in the room? Y bar is the tallest person. That's what we're trying to do. I hope that's clear. This has to be very rock solid clear because when you form the likelihood ratio, that's what you're doing. You're finding the value of the maximized likelihood in two different places. That's right. When you're allowed to see everything, and when you're allowed to only see within the doubt. Basically, that's what's going on. All right. Lastly, 653. What's the rejection rule? Is it intuitive? The rejection rule is if my likelihood ratio is small, then I should reject the null. Why? Because what you have set under the null is not cutting it. It doesn't do a very good job in maximizing. It's quite small. So it means the null should be thrown in. So you decide to reject the null in favor of the alternative if your likelihood ratio is small. Now, the finding of the C is where we are going today. How do we find out this number? Once again, just like the finding of the K, how do we find out this number so that the probability of rejecting the null when the null is true is 5%? That kind of thing. So I will help you, right? So that's where we are going right now. So let's see, where did we stop the last time? We stopped actually at part C. I remember that's right. Basically show that, I asked you, but he showed that the likelihood ratio when you put in these values is equal to this. Right? And then finally, we have Yeah. So now what am I saying? Find out what C should be so that this rule has type 1 error probability 0.45. Okay. So we all should have come to the same conclusion, which is this is okay. So now I'm saying this rule can be written as reject. Okay. Write the rule first. All right. Write down the rule first. The rule says reject null when e to the whatever is less than. That's the rule. Oh, you did already. That's awesome. Good. Okay. So we have that. Okay. Now your job is this. Find C so that this happens with what probability? I want you to find C so that this happens with probability 0.05 when the null is really true. And what does that mean? When the null is true, what is mu? When the null is true, mu really is. In other words, can you find probability of rejecting null and put in the subscript what's the truth when mu is really 5? That's the point. And you want that probability to be 0.05. So you can set up that probability statement. All right. We want this again finding a type 1 error probability.